So I thought I would do a little bit of work with you online regarding 3 of these homework assignments. We're going to take a look at 47, 48, and 60. So here's number 47. In number 47, you're given 3 naturally occurring isotopes of potassium. One of the isotopes is 38.963707. Another isotope, is 39.963999. And the third isotope, we don't know. So we're trying to find the mass of the third isotope. Okay, we know the percentages of the isotopes because we know that 39, isotope 39, which is the 38.963707, is 93.2581%. So 93.2581%. And we know that the other isotope is 6.7302%. 6.7302%. So we're trying to find the isotopic mass of the other isotope. So if you have a calculator in front of you, if you did 100 for the total percentage of 100% minus 93.2581 minus the 6.7302, you'll find that the third percentage is not very much, 0.0117%. Now, if you remember when we, at the end of class today, we talked about how to find the average mass would be to take this number right there. So, lost my cursor. So this number times this number. You would add that to this number times this number. And you would add that to this number that we don't know, which we would just call x, plus this number. Altogether, the actual atomic mass for potassium, I have to look that up real quick, so I thought it would be listed there, but it's not. So the average atomic mass of potassium, based on the table on the inside of your front cover of your book, is 39.0983. So that equals 39.0983. So now you have a problem where you can just solve for x. So that times that, plus that times that, plus that times that. Oops, that's supposed to be a time sign. Sorry about that. So back up, that's a time sign. So this times this, plus that times that, plus that times that will give you this answer. So now you can just solve for x. There is one other catch though. Remember at the end of class today I said there are 2 ways you could work this problem that we were working in class. You could multiply by these 2 numbers together, and these 2 numbers together, and these 2 numbers together, and then divide by 100 at the end. Or you could divide at the beginning. And so in this problem, it's better to divide at the beginning. So you would use 0.93258. Write that down. 0.93258 instead of 93.2581. And then you would use 0.067302 instead of 6.73. And then you would use 0.0001, no, 0.000, sorry, 117 here. So divide by 100 before you start, and then solve for x, and you'll have it. All right, 48. Similar, you got 2 isotopes. The actual mass of the boron 10 and boron 11 is 10.012937, and the other isotope is 11.009305. We know we're going to multiply that by their abundance, whatever that abundance is. Let me separate these problems. All right, we're going to add this number times its abundance, whatever that abundance is, and that's going to equal the actual mass of boron, which in your book is 10.811. Now, once again, I'm getting these from the periodic table inside the front cover of your book. All right, so this number here will be the abundance, and this will be the abundance, which is these percentages up here in decimal form, not percentage form. So we know that if I have two different isotopes, I could have whatever x, I could use x plus y equals 1. So if I have 100%, like suppose one was 80% and one was 20%, 80% plus 20% is 100%. But if you divide by 100 before you start, then it's 0.8 plus 0.2 equals 1. So I think the way you'll be most familiar with is to say, we'll call this one X. Whatever percentage of this isotope exists, we're going to call X. And we can call the other one Y. But it's probably easier for you to write Y as 1 minus X. So if you just subtract X from both sides, subtract X from both sides. See, the X is canceled over here, so you'd have Y is equal to 1 minus X. So now you can use algebra skills to solve the equation. Then you'll know that the 10 isotope is whatever this X is, and then subtract that from 1, and you'll have the abundance of the other isotope. If you want percentages, then you multiply by 100. All right, then 60. And you turn back to number 60, page 60, which is actually page 62 now. We've gotten up to 63, 64, got to page 64. All right, so number 60, you have 75 cubic centimeters or 75 milliliters of solder. Okay, we know it's 67% lead, and solder has both lead and tin, and the density is 9.4 grams per cubic centimeter. Okay, that's 67% lead. Now, if it's 67% lead, then that means it's 33% tin. I think that would make sense because 67 and 33 makes 100. All right, so if I multiply this out, my total mass of the solder, total mass is 75 multiplied by 9.4. So I have 705 grams of solder. But of that 705, you know that 67% of it, or 67 over 100, there's 67 grams of lead for every 100 grams of solder. And that would give you the number of grams of lead. So 705 multiplied by 67% is 472 grams of lead. Okay, that's 472. I'm going to leave that at three significant figures. So that's 472 grams of lead. If I take the 705 grams, multiply by the silver, or the tin, it'd be 33 over 100, because there's 33 grams of tin for every 100 grams of solder. So 705 times 33 over 100 is 232. We'll call it 233. It's 232.6. Okay, so 233 grams of SN. Now, if you look back at the question says it wants to know how many total atoms are present. So the next step, which I'm out of room to do, so I'll tell you, change this to moles and change this to moles. Okay, that's using our mole conversion factors that you learned in year 1 of chemistry. So 472 grams times 1 mole over 207 grams. After you have moles, you can add them together. So you take this number of moles, add this number of moles, and then multiply by the Avogadro's number, which is 6.02 times 10 to the 23rd. At that point, you'll have the answer. So you take this, change to moles, take this, change to moles, add the 2 moles together, and because that would give you total number of atoms in moles, then multiply by 6.02 times 10 to the 23rd to get the actual number of atoms. So I hope that helped a little bit. It's kind of fast. You have to use this in conjunction with your answer book. And that's the end of what I have time to do today. So we will talk in class on Friday.